So today is lesson 4 from chapter 8. It's titled Factoring Trinomials again, which you might notice is the title from our previous lesson, but this time we're going to be factoring trinomials in the form ax squared plus bx plus c. So the difference today is now that first term, that x squared term, is going to have a coefficient in front of it. So when we factor trinomials in this form, some of the rules are going to stay the same, like in terms of your signs. But first I want you to write down your two sets of parentheses. Then you're going to break that first term down into its factors and the last term down into its factors, and then check to see, can you get the middle term by multiplying those outside and inside pieces that we do when we FOIL. And then we're going to make sure that we're using appropriate factors that work, and our sign rules, again, our same sign rules will still apply. So here we go. Our first expression, 2x squared plus 5x plus 2. So we're going to go ahead and write down those two sets of parentheses. And what I typically will try to teach students, particularly when we get to more numbers that have more sets of factors, that we start with one set and we check everything else before we start switching things around. Sometimes you can miss stuff. What's nice about this example is that both that a x squared term and the c term are both prime numbers. So the only way to split up 2 is 2 and 1. And the only way to split up 2 back here is 2 and 1. So now it's just finding the right combination to get us a 5x in the middle. So I'm going to go ahead, I'm going to put 2x here, and I'm going to put x there. And my back sign is positive, which means my signs are the same and they match the middle term. I'm going to just go ahead and split up 2 from the back into 2 and 1, just like we had done yesterday. And I'm going to check, can I get 5x in the middle? So when I multiply here, that's 2x. When I multiply here, that's 2x, and that only gives me 4x. So the combination of how I have them laid out here didn't work. So now I'm going to switch some things. And again, this is where I tell students only switch one set. Don't switch them both because you'll miss things or you end up having the same answer you just had. So I'm going to switch the 2 and the 1 in the back. It's just a lot easier, I think, to switch those pieces. I'm going to put a 1 and then a 2. So when I multiply here, I get 1x, and when I multiply the outside terms, I get 4x, 2x times 2. And now when I add those together, I do get 5x, and that's what I need in that middle term. So as long as I've got factors of that first term in the fronts, and I've got factors of the last term in the backs, then I just have to make sure that I can put them in the right spots, that right combination to get the middle term. So let's try another one. 6n squared minus 23n plus 7. So we're going to write down our two sets of parentheses. I do tell students this also. Start with a prime number if there is one, because there's only one set of factors, and you can put it in its place, and then you don't have to move it again, and you can just be switching the other factors. So let's start with 6. 1 times 6 and 2 times 3. So I have a couple different sets I might have to try. 7, though, is just 1 times 7. The sign is positive in the back, which means my signs will be the same and they match the middle term, so they're both going to be subtraction. Since 7 is prime, I'm going to start back there. I'm going to put a 1 and then I'm going to put a 7. And I'm not going to move them or change them. If I have to change or move anything else, I'll do that. So with the front. So let's just try 1 and 6. It really is guess and check from here. Some of you will start to see it in your head a little sooner, like, oh, there's no way I can get negative 23 if I do this, so you might try a different set of factors. So I'm going to try 1n, and I'll just write n, and then I'm going to try 6n. I'm going to see if I can get negative 23 in the middle. So that's negative 6n, and here we have negative 7n. Well, that's negative 13n. I need negative 23, so that didn't work. Okay, I'm going to switch the 1 and the 6. So instead of putting the 6 in the back, I'm going to put it up front. Notice I didn't move the 1 and 7. That's prime. I know it has to be 1 and 7. It's just figuring out which combination of the front factors work. Okay, and now you can maybe see kind of quickly 6 times 7 is negative 7 is negative 42. So there we go, negative 43n. So still not correct. That means since I tried the 6 and the 1 both ways, this doesn't work. Now it's going to be the 2 and the 3. And if you can kind of visualize a little early, I can see it is going to be 3 here and 2 here, but it might take you 2 tries to figure that out. This is going to give me negative 2n, and the outside terms are going to give me negative 21n, and now when I add those together, that is negative 23n. So there we go. To factor, we have 3n minus 1 times 2n minus 7. Number 3, 2n squared minus 5n plus 2. Check out how this one differs from number 1. So again, my parentheses, I have 2 prime numbers here again, 1 and 2 and 1 and 2. So what's different from number 1? Well, my back number is still positive, so my signs are going to be the same, but this time they're going to match the middle. So think about how does that affect anything? How does that affect anything else in the parentheses if I just have 2 subtraction signs instead of 2 addition signs? And it turns out it doesn't. So if I go back to number 1, I had the 2 first. So I'm going to put the 2n here, and then I'm going to put just the 1n back there. And I want the 2 from the back number in the back, and I want the 1 up front. So here we go, negative 1n. And minus 4n, and that's going to give me that negative 5n middle term. Number 4, 5m squared minus 14m minus 3. So how can we factor? Again, a nice one because both of these numbers are prime. So we won't have a lot to guess and check with. You can start in the front, you can start in the back. Since both of them are prime, I'm going to go ahead and start in the front. I'm going to put m first and then 5m next. Now the back number is negative this time, so I need 1 positive and 1 negative, and I don't know initially which one's supposed to go where, so I just pick. I might be right, I could end up being wrong, and then it's a quick switch. If you end up with the signs backwards, I'll show you what might happen there. So in the back, I need to get a 3. So I need factors of 3. So let's do 1 and 3. So this gives me 5m and a minus 3m. Well, that's only 2m. I need a negative 14 in the middle. So let's try to switch the 3 and the 1. Again, notice I'm not switching both sets of factors. I only ever switch one at a time. This gives me 15m, and now I have minus 1m, and that is positive 14m. So here's the quick switch. When you get the right number in the middle, but the wrong sign, we correct that by just switching the signs in the parentheses. Now I need a negative or subtraction sign in the first one and an addition sign in the next one. Now I have negative 15m and a positive 1m, and that is going to give me negative 14m. 2x squared plus 1x, or just plus x, minus 3. Again, got some prime numbers here, 1 and 2. 1 and 3, so I can start either in the front or the back and place those in. So let's do 2x and x. Back number is negative. That means I need 1 of each sign. And let's go ahead and do 1 and 3. So this gives me 1x, and the back, or first and last, give me negative 6x. That's negative 5x. That's not the correct middle term. So I'm going to switch the 1 and the 3. Again, not switching both, just switching one set of factors. This gives me 3x. This gives me minus 2x, and there we go. There is my positive 1x or positive x term that I need in the middle. 6, 20m squared minus 31m minus 9. You're going to notice here much bigger numbers for A and C, lots of sets of factors. So I'm going to list them down below this time. 1 times 20, 2 times 10, 4 times 5. We have 1 times 9, 3 times 3. And if you want, you can kind of look at the factors together and try to think, man, how can I get a 31? You're going to be multiplying these different sets of factors together, and sometimes it is hard to see in the beginning. So let's go ahead and split up our parentheses. My back number is negative, so we need a positive and a negative. And really, you kind of have a choice. Where do you want to start? In the front, in the back? What set of factors do you want to try? We really need all the different combinations. There are 6 possible combinations before we even start messing with signs. So let's see. Let's just start with 1 and 20. M and 20M. And then in the back, 1 times 9. So I'm going to put a 1 here and a 9 there. This gives me 20M. This gives me minus 9M. So that is 11M. And that doesn't work. So before I try to change the factor to something else, I need to switch them spots. And you're going to see quickly that multiplying 9 times 20 is 180M. This isn't going to even come close to negative 31 that I'm trying to get in the middle. So 1 and 20 do not work with 1 and 9. So I can actually take 1 and 9 all the way out now. And now I'm going to try something else. Let's try 3 and 3. 3 times 20 is 60M. 1 times negative 3, that's negative 3M. That's only, that's 57M. We're getting closer. The interesting part here, though, is that if I switch 3 and 3, I'm still going to get the exact same thing. So now I know that 1 and 20 doesn't work with 3 or 3 either. So 1 and 20 doesn't work with 1 and 9, and 1 and 20 doesn't work with 3 and 3. That means 1 and 20 doesn't work. So now I'm going to go on and switch to my next set of factors. I got to give a little more room here. Let's do 2 and 10. And I'm going to first try them with 1 and 9. So that's 10M minus 18M. That's negative 8. I need negative 31. That's 9M and, excuse me, that's a 9 and a 1. I flipped the spots, so that's 90M minus 2M. Okay, that doesn't work. So that means that 2 and 10 don't work with 1 and 9. Do they work with 3 and 3? So this is 30M and minus 6M. Okay, we're getting smaller numbers here. Now this is 24M. Switching them spots would give you the exact same answer. So now 2 and 10 also don't work with 3 and 3. So now we're down to our last set of factors for the front. I'm going to leave those 3's in there instead of switching back to the 1 and 9. Let's put a 4 first and then a 5. Okay, that's 15M, and that's minus 12M. Now that doesn't work either, that's 3. Switching 3 and 3 spots won't matter, switching 4 and 5 spots won't matter, so now we're all the way down to, it hopefully is 4 and 5 with 1 and 9. So let's try it here. This gives me 5M, oh here we go, negative 36M, for a total of negative 31M, and there it is. Is that guess and check process exhausting? Yes, sometimes it is. Do you need to make sure you have an eraser? Absolutely. Sometimes we get lucky and we just try one in the beginning and it works, or one of the first few we try work, but that you can see now the process of how many different combinations there are to check for all of these. And I think if I switch, there were 9, 3, 6, and 9. Yeah, 9 of them. Okay, moving on. 2x squared minus 12x plus 10. So this is the first example where we need to talk about the greatest common factor in these terms first. So when you have an expression, you want to look at it and see, can I take anything out first to make these numbers a little smaller? And here you can. Hopefully you recognize that all 3 terms are even, which actually means I could factor out a 2 first. This is why we did some of that work. Whoops, that's not 12 anymore, it's a 6. That's why we did some of that work in the first few sections of factoring out the greatest common factor. So now you can see that this new parenthesis here is much easier to factor than the first one. I have fewer sets of factors. I actually have 2 prime numbers. That x squared has a 1 in front of it. That's what we did in our previous lesson. 5 is prime. This should be a lot simpler. So this is back to yesterday's lesson. X is in front, back number's positive, my signs match the middle, factors of 5 are 5 and 1, that's it, so that gives me negative 5x. This gives me negative 1x for a total of negative 6x. But we have to remember that this 2 we factored out is part of the solution, so we do need to make sure we bring it with us, and it is part of the answer. So completely factored, we pulled the 2 out first because every term contained a 2. Then we were able to factor a much simpler trinomial. This is the first example today where we've had a GCF, a greatest common factor, in all 3 terms. If I just go back to one slide, 20, 31, and 9, they don't have anything in common that I could have factored out. Here are the factors right here of 9. Here are the factors here of 20. They don't have anything in common. So now we're going to make sure we always check for the GCF because it makes things simpler. Check for greatest common factor. Number 8, 4m squared plus 14m plus 6. So what do they all have in common? Again, they're all even numbers, so they're all definitely divisible by 2. Does anything else go into them that's bigger? 3? Nope. 4? Nope. That's it. Okay, so we're going to factor out a 2. That's 2m squared plus 7m plus 3. That's what we're left with. That's what we're going to factor. Much nicer again. 2 and 3 are both prime. I like to remind students actually bring this 2 down first so you don't forget. It is part of the answer. So now we need to split 2 up. Its factors are 1 and 2. We're going to split 3 up. Its factors are 1 and 3. We need a combination to get 7m in the middle. So let's try 2m and m, and let's try just 1 with 3. My signs are the same. They match the middle term. They're both addition. Here we go. 1m and 6m. Oh, got it right away. Cool. That is a total of 7m. You are factoring, once you take out the GCF, you are then factoring what's left over. Not back to the original problem, just what's left over here. We created a simpler trinomial and we were able to factor it. So the factored expression is 2 times the quantity of 2m plus 1 times the quantity of m plus 3. If I FOIL this back out, multiply everything by 2, I get my original problem. 18y squared minus 12y minus 6. All of these numbers are divisible by 6. So we're going to factor out a 6. 3y squared minus 2y minus 1. Again, much simpler. The number 18 itself has 3 sets of factors, 1 and 18, 2 and 9, 3 and 6. That's a lot of different factors to try. Now I have a 3 in the front, 3y squared. I only have 1 set of factors for 3, 1 and 3. Same with 1, it's also prime, 1 times 1. So now it's just finding the right combination to give us that minus 2 in the middle. So 3y and y. My signs are opposite because the back number is negative. Let's do minus and plus, 1 and 1 in the back, and let's make sure we get a negative 2y. So there's negative 1y, but that's a positive 3y. That's going to give me a positive 2y. Remember the quick fix, when you have the right number for the middle term but the wrong sign, you just switch the signs in the parentheses. We want addition first and then subtraction. So that's going to give me a positive 1y. It's going to give me a negative 3y, and that combines to give us negative 2y, which is what we need in the middle. Number 10, 20x squared plus 17x plus 3. Nothing can come out of any of these terms. There's no greatest common factor. 17 is prime, 3 is prime. So we're just going to have to list the factors of 20. 1 and 20, 2 and 10, 4 and 5. Our only factors of 3 are 1 and 3. So this won't be awful because we know that we have to have a 1 and a 3 in the back. My signs are addition, both. They match the middle term. And now I need to start splitting things up. 12 and 5. Oh, that works. Okay, I'm going to start down at the bottom this time. I know that the guessing and checking is going to be a little less since I already know what it is, but I just want to show you again the process of getting it wrong and what you do to try to fix. So let's try 5x and 4x. So I'm starting down here with these factors. Students do find or start to notice that sometimes those smaller factors work a little more often than the bigger ones, like 1 times 20. You'll see 4 times 5 working more often. So this gives me 4x, and this gives me 15x, and that is 19x. So that's too big. Now I have an option. I can switch the 1 and the 3, or I can switch the 4 and the 5. Since the factors of 3, since 3 is prime, I'm going to leave the 1 and 3 there the whole time I'm working on this problem, and I'm going to just switch the 4 and the 5 first. Before you start working with another factor, make sure you switch those 2 places first. If you go ahead and jump right to 2 and 10 or 1 and 20, you've missed this combination of pairing numbers together. This gives me 5x, this gives me 12x. You'll see that is a total of 17x positive. So there we go, we got it. 4x plus 1 times 5x plus 3. Okay, there are 2 more examples, and I'm not going to work through them here in the video. I'm going to have you try them on your own and see how you do with factoring. So number 11 is 3x squared minus 7x minus 6. Don't forget to check if there's a greatest common factor first. And number 12 is 18x squared plus 33x minus 30. So go ahead and work through both of those. We'll go over them at the beginning of class so you can check to see if you got it right. I will check your notes and we will work on worksheet 8.4a.